Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at specific molecules or organic molecules that we're trying to give a name. And in this case, we're going to look at a different way in which we are going to identify the functional groups in these specific molecules. And we're also going to look at the order in which they can be given priority in case there are two substituents that can be considered to be functional groups. So in this case, this is a practice exercise, and we're going to identify these organic molecules and try to see which class they fall or which category of organic molecules that we are trying to look into. So without further ado, thank you and welcome. So as I've said, today is a practice exercise. We're going to look at the specific molecules that I've drawn on the board, that is for 1, 2, and 3, and try to identify them and put them in a specific class that they belong. So in this case, if we try to look at these molecules, we talked about functional groups, a summary of functional groups in one of our videos, and that is going to assist us to try and identify which kind of molecules these ones are. So I'm just going to introduce a small column in the middle, which is going to assist us in listing some of the characteristics that we can be able to observe from these molecules. So for the first one, if we try to look at it, there's what we call a double bond. So this one gives us a clue that this specific kind of a molecule consists of a double bond, and then we are going to identify that this is a cyclic, which means it does not contain of a cyclic, so it does not have a cyclostructure or a ring structure in its, it does not contain a ring in its structure. Number 2, it has got a functional group that we can identify, of course, from this one. This one, we just encircle it. We can identify this functional group from this particular point, which is a functional group for carboxylic acid. And then what else can we be able to identify? Of course, that is it. And then number 3, we are going to look at the number of carbons. Of course, that one can assist us somewhere, the number of carbons in that molecule. So in us to consider the number of carbons, we can see that the main functional group in this case is a carboxylic acid that I've listed in point number 3. So for carboxylic acids, they have a general formula, which of course we can just be able to draw. This is OH. And that H there is different from alcohols, which is a proton, of course. So we're going to have a general representation for carboxylic acid at that point, and this is known as the carbonyl carbon. So for assigning the name or identifying that compound, the numbering for us starts at the carbonyl carbon, and therefore from there we are going to proceed and try to give the numbering for this chain of paraphatic compound. So this is carbon number 1, 2, 3, 4, 5, 6. So in naming this, we said that the name comes from, the parent name comes from the alkane series. Now for a 6-member ring, we call it butane. So from the alkane series, we can be able to identify, we call it hexene. It's a 6-member ring, sorry for that. Hexane, that is for an alkane series, where we derive the names from for a 6-member carbon ring. So next, after identifying that, we are going to see at what position the double bond is. Now that we have identified the functional group at this one, so this is 1, 2, 3, 4. So at carbon number 4, there's an attachment of a double bond at that particular point. So insofar as our naming is concerned, we've said that this is a carboxylic acid, therefore it's going to contain this one. It's going to contain, of course, we talked about the prefix and suffixes, or the suffix for that particular kind of compound. Now, in our previous videos where we were trying to talk about the configuration of an atom that consists of a double bond and different molecules are those specific points, we said that we can be able to give it a designation for the term Z, Susamen, and then for E, antigen, which specifically, of course, refers to the term across, and then the next one refers to the term together. So in this sense, for Z refers to together for molecules which are of either low or high priority, which are appearing on the same side or at the same side of the carbon atom. And then we talked about which are appearing on the same side. And then we talked about antigen, which refers to the concept of across. Of course, in this case, we're going to look at this one and try to identify which class these molecules fall. Now, for molecules which, of course, have substituents that have got the higher priorities on the same side, that one we're going to give them the Z designation, and therefore we're going also to consider that concept in naming of this specific compound. So in this case, going forward, then we'll be able to try and name it. So as we have said that these are molecules with high priorities that have fallen on the same side, therefore we are going to give it a designation for Z. And then next, we're going to identify the position of the double bond, which is 1, 2, 3 for blue, carbon number 4. And then next, we're going to see the number of carbon atoms which are formed in this compound. Of course, we said that so from the hexane, from the alkane series, 6 carbon atoms hexane. But since it has got a double bond in this ring, then it's going to be hexene. So hexene. This is a E. Hexene. Z4 hexene. Now, for non-cyclic compounds, carboxylic acids are named by replacing the E of the corresponding alkene by oic acid. So in this case, of course, as we have said, for this one, we are going to give it a "in" for double bond. But whenever we are naming carboxylic acids, we do that by replacing the E of the corresponding alkene by oic acid. So we are going to have this E, hexene, replaced by oic acid. So therefore, that one can be named as Z4 hexenoic acid. So that's for the first part. So for the second one, we are going to look at also some of the specific rules that apply. We talked about, of course, we're going to look at in configuration, of course, conformational studies, we're going to look at there's different projections, specific projections on how we can be able to represent molecules. And some of the configurations, some of the specific rules we're going to use for configurations in order to show the three-dimensional projection or maybe structure of molecules. So in this case, I presume that from one of our videos that we have discussed, we're just conversant with a kind of a molecule. So if you try to look at the characteristics, or just a conversant with the configuration that I've just used for the second molecule. So if we try to use the specific rules that we have discussed, this is also from this part of the molecule, we can see that there's an order for the Z and E. There's an order in which we are going to use that one. And we have seen that we can be able to look at this section of the molecule whereby the CO, the carboxylic acid functional groups lies across. So that one we're going to use the term, just list the others, just the one we said. So this one consists of a cyclo group. Number 2, there's a carboxylic acid functional group. And then number 3, what else can we see? The number of carbon atoms for this. 1, 2, 3, 4. 1, 2, 3, 4. Okay. That's 1, 2. So in this case, when we are trying to do a numbering for carboxylic acids, of course, we said we give the substituents the lowest or the position of the functional group, the lowest numbering combination possible. So for our numbering, it's going to be from this particular point. We can start from here. This is 1, 2, 3, 4. So that is going to give us, of course, a compound that consists from the cis and the trans designation that we talked about. These are just compounds that lie across. Therefore, we are going to give it a designation for trans. And then next, we can see that we've said it is cyclo. So for the carbons, it's a 4-member carbons. And there are 2 functional groups, so this is going to be a di for carboxylic acid. And then, okay, let's try to look from these observations that we have listed and try to see how we can be able to name it. So first, as we have said that the carboxylic functional groups lies across, so therefore we're going to give it a trans. And then the position of this carboxylic acids, that is 1, 2 cyclo, it's a cyclic compound. 1, 2, 3, 4. From the alkane series, this is bute. Of course, it's a saturated compound, so therefore it's not going to have, so it's going to be butane. And then there are 2, so that is di-carboxylic. So apart from the term, this particular condition that we have given for the first one, this is for aliphatic carboxylic acids. There are other ways in which we are going to denote this carboxylic acid in a way that when it's a cyclo, unless it has got specific names like benzene, if it's a cyclo, then we're going to end or have a suffix that is ending with carboxylic acid. So in this case, compounds that have a carboxylic acids bonded to a ring, then we name them by using the suffix carboxylic acids surname. So I've just used the term di because there are 2 of them. So the name for this compound will be trans 1,2-cyclobutane dicarboxylic acid. So let's try to look at the third one and try to see also how we can be able to name the compound. Now in this case, this is going to be easier for us. Let's try to identify the functional group in this compound. Of course, as I've said, we have also priorities for these functional groups and whether we can consider functional group or a substituent. So in this case, when we identify the functional group as a carboxylic acid and then the other substituents there, we're going to consider it, or the other molecule we're going to consider it as a substituent. So therefore, as we're going to do the numbering for this case, for carboxylic or for the benzene molecule, it has got specific names for these different points of attachment for the substituents. And the first one here is known as ortho, this is known as meta, and this is known as para. Now this one are named with respect to the position of the functional group in a way that molecules or attachment or substituents that appear at these points with respect to the functional group are named using a designation for ortho. So we have ortho, and then if they appear at these particular points, then we name them meta, or if they appear at this specific point, then we name them para. Now for our case, the substituents appears at the ortho position, so we are going to have to retain that name or designation for that. Number 2, we have identified that it's a carboxylic acid functional group. And then number 3, there is a substituent that is attached at point number, or just at the position of ortho that I've said. So there's an ortho hydroxide group. So therefore we just go ahead and try to name our compound and try to see what it is. So for the nomenclature, there's a rule that this position for the substituent is indicated as such. So ortho hydroxide is an hydroxide group. See, this is ortho hydroxide, and this is known as now that all of this is known as a derivative of a carboxylic acid derivative, of course, a carboxylic acid that contains the benzene ring. So we're going to name it benz. Now, since we have considered all of this, then it's going to be benzoic acid. So therefore, our molecule is going to be known as ortho hydroxy benzoic acid. So as we have been listing these specific compounds, it is therefore right to say that they fall under a similar class of what we call carboxylic acids. And therefore, as I said, this is how we can be able to identify this class of organic compounds and try to see, of course, as I've said, for cyclic compounds or for carboxylic groups that have got a ring in their system, we use the suffix carboxylic acid, whereas for the aliphatic ones that you have talked about, we substitute the E using white acid. So in this case, of course, that is going to give us a clue on how we can be able to be naming those acids going forward. So this class of organic compounds are very important, of course, because it's good always for us to know the relevance of whatever compound we are being discussed or these specific applications for us to be able to appreciate it. So in that case, it's very important for production of polymers, and then it can be used, of course, for production of compounds that are used for coating, adhesives, pharmaceutical products, food additives, and microbials, and for flavoring. So this we're also going to see that there are different ways in which we can be able to achieve this functional group, or maybe the products of carboxylic acid through oxidation of course, alcohols or primary alcohols, etc. So in this case, this is where we're going to stop for today. I hope that this discussion for the sample questions, or maybe for practice for us, is going to cement on what we have already discussed in some of our videos concerning nomenclature and the reaction, or maybe configuration of these particular molecules. So for that case, that is it for today. Thank you guys. Bye. God bless.